Welcome back. And now let's go on with our journey, and this time we will look into the dependency inversion. The dependency inversion principle changes our design. You can see again here the class diagram. What is different to the previous step, to the dependency injection, is mostly here in the bottom part. In the previous step, in the dependency injection step, we had a common interface that image sensor A and image sensor B implements, but actually that interface is now gone. And there is another interface. This is the image source. And then this interface is implemented not by the image sensor or image sensor B, but actually this is implemented by an adapter. And then this adapter is using one specific type of sensor. This is the image sensor A. You can see it is even hard-coded in the name, image sensor A to image source adapter. So from the name, it kind of suggests that there will be some transformation or some adaptation from image sensor A to image source interface. But let's see why it makes sense, or how does it make sense, or if it makes sense, if we have a deeper look on in the implementation. So we have again the image sensor A and image sensor B. We have the very same implementation like we had since the beginning, but the difference here now, the interface is gone. So as you can see, the image sensor A or image sensor B doesn't implement any kind of interface. There is no common denominator interface, and we will see then how it is going to work out. There is also another change in the image enhancement algorithm in our business logic. We still have the dependency injection, so that we get our dependency from outside. But this time we don't get that interface, we don't get any kind of specific sensor, so we don't get an image sensor, an image sensor A or image sensor B or an image sensor interface, because that interface doesn't exist at all now. But now we will get one instance of this image source interface, and this is what we are using. And then this interface here is it contains only one function, this fetch photo. You remember in the previous step for the image sensor, the common denominator what these two functions can offer, and the offer, this is the key point here, that image sensor A and image sensor B, they both offer taking a photo and then starting a video or taking a video. But actually, this one now is just an image source. It is expressing that I need an image from whatever source it is, and then I want to fetch the next photo. And then in this image algorithm, what we need here is that basically we don't care from which sensor or from which source the image comes. We just only care that we need a photo wherever it comes from, and then we will process it, and that's all, and then we will return it back in this function. And now this is the key difference here, is that before the interface, as I already mentioned, was expressing what image sensor A and image sensor B both can offer. But now this interface is not an offering interface, but it is a requirement interface. So basically, we are kind of flipping here the purpose of this interface, because you see that I need something in this algorithm. I need something that I can fetch a photo. But because this fetch photo, there is no such function on the image sensor A, so I can't just go and then simply go and then implement this interface. But actually what we will do here, we will have to somehow bridge over the gap between what the interface requires and then what, let's say, this image sensor A offers. Because image sensor A can offer us a picture, to take a picture, and then it requires that, but they are not really the same. We need some kind of translation that is done here, and then this is called the adapter. This adapter design pattern is a very old one, was already part of the Gang of Four. This is probably the first book that deals with design patterns. And then it works this way. So it implements an interface, and then um, here this interface is adapted maybe to another interface, but actually in this case it is adapting to this concrete sensor type. So that's why the interface name and also the adaptation target appears up here in the name. This slide shows here the last important thing in the dependency injection, the composition root and the image sensor A to image source adapter. So basically the adapter that is adapting between this interface and then the sensor A. Let's have a look how it is implemented. Of course, it implements the photosensor interface, and then in the constructor it takes the image sensor A. So it is again something different, because now we are injecting not an interface here, but we are injecting here a concrete type. This is of course also possible. And then what is happening? So because we are implementing the photosensor interface, that's why this fetch photo function is implemented by the adapter. And whenever somebody calls the fetch photo, then this call is forwarded to the sensor, to the sensor A, and then it takes the photo and then returns the image. So it means that whenever the image enhancement algorithm needs a new photo, then it just goes to the interface, and then the interface is going to is implemented by the adapter. So basically through a virtual function call, we come here, and then after the virtual function call, we have a delegation, so here. And then we jump into the image sensor. The image sensor takes the image, returns it back here. So this is this when we are returning from this function. And then we are just returning back to the algorithm. So basically here, this image is returned back to the algorithm and we have it. The interesting thing here with this image sensor is, as I already spoiled it before, but this image sensor interface, what we used to have here, this was a kind of an offering interface. So what is the least common denominator that all image sensor offers? But now this was flipped around, because now we have such an interface that is not offering something, but actually this is requiring something. So it means that the image enhancement algorithm expresses its needs, its requirements in the form of an interface. But because this requirement is not directly fulfilled, because the image sensor A offers something different, that's why we would need here something that is bridging over the gap between the requirement of this interface and then what this concrete type offers. And that's why we have here this adapter. So it means that when we are building up the system, again, bottom up, just as usual. So first we create the image sensor A, and then we create the adapter, and then we plug into the adapter the sensor, so basically the dependency injection. And then this adapter, because then the image enhancement algorithm needs an adapter, or not really the adapter, but actually it needs some kind of image source. If it is an adapter, it doesn't really matter for him. But actually, in this case, at the product level, it really matters. And now we are injecting the adapter into the image algorithm, and then the rest as it used to be. So there is nothing new here. And if we take a step further, then we will see the real difference. So in the previous step, probably you remember that we had here the image sensor interface, this offering interface. But now the interface disappeared from here and then it popped up here. But actually this is not now, it is a requirement interface. It is not an offering interface. and then it is packed together with the image processing lib. Probably you remember in the previous step, we had a dependency from the image processing lib to the camera sensor library, because the interface, the camera sensor interface was here, and then this was using that interface, so the algorithm was using that interface. But now we package this image source interface together with the image enhancement algorithm. That's why the dependency is inside this library. So this one depends on this one, but actually this is on inside the same library. That's why there are no external dependencies of image processing lib. And this is really a key achievement, because this is now business logic, and then this business logic does not depend on any hardware, on any UI interface, and actually any kind of wiring or glue code. And you can just take this business logic now, then you can sell it to your customers, and then they can build it into their application, and then they can use it however they want to use it. Let's have a look on this setup. So this is the classical application as we started. So we have a UI application that depends on a UI library, and then also depends on our business logic, so the image processing library, and then here we have the camera driver code. And we need from this application these three components to be able to build up a product, because basically the executable is the product, and these are components. But now we want to build a command line tool, and then in this command line tool we again have a product. So this is again the wiring, the composition route is here, and then also the adapters are here. And this product depends on the camera sensor and the image processing lib. So we already see some kind of code sharing. So out of these three libraries, two is already shared. So we have 2/3 of the code shared by two products. So imagine if you have to fix a bug here in this camera library or in the imaging, then if you fix it here for the UI application, then you automatically fix it for the camera tool. You remember in the very first level, this was not possible. However, what is special here is basically that instead of the UI, we have some CLI, some command window where you can issue commands to the application. So this is a very big step forward. Okay, now we came again to the pros and cons. And then, as we have seen already on the dependency inversion, we keep control over the class dependencies by defining interfaces. So this is nothing new. This we already had in the previous step, but we still kept this feature, and this is not missing. But now we have some more insight, and then we know that if we flip over the interfaces, so instead of offering interface, we can also create requirement interfaces, and that's why the interface can move from one library to the other. And with the interface, also the dependency between libraries move. We can quite easily invert the interface side, and this one also reverts the dependency. So or either eliminates the dependency or it inverts it. Now we have already discussed about this. The core value is not dependent on anything, and this is really a big achievement, and this makes it independent of any kind of peripherals. And then this is also another interesting and positive thing, that we don't have to define an interface with the lowest or the least common denominator in a form of an interface. So the more sensors you will have, the least commonality you will find. So at the beginning we had just maybe taking a video and taking a photo. This is the same, but probably there will be such a sensor that can only take video but cannot take a camera image, so a still image, and then because of that you have to remove the take image. But if you remove the take image, then also with the other sensors you are not able to take image, and then you will make different versions and flavors of interfaces, and then basically the interfaces, instead of becoming an abstraction, they will become so much coupled with the implementation they become unusable. Now we have product variants. We already seen this CLI and GUI approach, and this is again very nice because we can reuse a lot of code, and then in some cases we can even inside one executable the slight variations we can cover. So if we have let's say a more complex and advanced UI and a simple UI, maybe we can cover it with this Acme camera application by just instantiating another panel from this GUI library. But if you have something more fundamentally different, then for example like the CLI tool, then you will have to involve other components and remove maybe some that are not usable for that scenario. Uh, Now we have these adapters, and these adapters are also called glue code because basically these are bridging over the difference between the interfaces, and then they pose a little bit of overhead. So if you look here in the call hierarchy, the image enhancement algorithm is making a virtual function call to the image source, and then because this interface is implemented by this adapter, that's why this call will land here. So basically we land here at the fetch photo, and then we are delegating the call here, so there will be another call. So one function call and then the delegation call. So we will have two calls, one virtual through the virtual table, and then one normal call. A little bit of overhead, but it is well worth it because we gain a lot of independence. Now we have full control over dependencies. We have since the dependency injection, we got control over the interface and class dependencies. And now with the dependency inversion, we also got control over the library dependencies. But actually, this is not really clear then what should be the rules, then which library should depend on what, and then why we have to cancel a dependency and then maybe do it somehow differently. And this here we have the mechanics how to do it, but actually we don't have yet the concept how to do it or why to do it. As always, here we try to bring some analogy from architecture, and then I took this mortar wall. Because you can see here we have the stones as our components. Probably you remember in the previous step when we had this in the dependency injection, the block stone wall. For that one, there was no mortar between the rocks, and that's why the rocks they had to perfectly match. And now you can see here we have really very diverse rocks. So we have this square shape, and this is this rectangle shape and the heart shape, and they can still fit together, and then you can build a wall out of that. So the wall would be basically the product. And then the stones are the components, and then the mortar here, this is the adapter code that is bridging over the difference, so that this heart shaped stone can fit to this square shaped stone. We need some mortar, some adapter between them, and then they can build up a wall. Just as a bit of a spoiler for the next step, then you can see here that this heart is in the middle, and then we have some other stones that are kind of surrounding, or they are on the peripherals of this heart stone. And then just imagine this stone is your business logic, and then all around you have your peripherals. And this spoiler already takes us to the hint how to level it up. And then, as I explained, if we can introduce here some kind of layering concept, then it would be clear that what component goes into which layer, and then if it is in the correct layer, then it already gives us some hint about the dependency directions, and then which dependencies are good and which dependencies are bad, and we have to somehow invert or eliminate the bad dependencies. So stay tuned, and then let's see next time what is the solution to this problem.